GM. Good morning, good afternoon, good evening. How's everyone doing? Did
Good
you all
afternoon.
have a good weekend? How was the weekend with scripting? Tell me here. Maybe you open your mic.
Good evening.
Good evening, Eva. Hello, everyone. Or maybe tell me here in the chat. Switching from interacting directly with the smart contracts with Remix that we did for the week 1 homework to testing now with scripts and sending those operations directly with scripts now in week 2. It's like consolidating this shift for having your own environment on your machine, that now you can code using TypeScript, you can code using tools, local development tools. Okay, so very important that you could get that working. If you have any questions or any problems still going with your environment, we still have time, okay? This week, and now in the week 3, we're going to do a project with tokens. Okay, we're going to understand ERC20, we're going to understand ERC721 using these scripts and tests. We're going to do a challenge together tomorrow on Wednesday. We're going to deploy a tokenized smart contract on Thursday, the tokenized ballot for picking what we understood of the ballot last week and then adding tokens to it. It's still using our environment. Okay, so it's going to be a full week of consolidating the things of using tests and scripts, operations with hard in TypeScript, okay, to prepare you for next week. That is going to be a heavier week where we do like full stack development, front end, back end, oracles. So I'm trying to say that there is still 1 week for you to sort out your environment, get started with the syntax, get to know hard, get to know VM, get to know those libraries that we are using. This week and starting today, full learning tokens specifically, but starting next week is going to be broadened for building applications. Okay. Good. So let's get started with the tokens. Study, understanding. Who here has ever used some tokens on chain, on mainnet for something? Tell me here in the chat, what kind of tokens have you been using? Dante, how many millions have you won and lost trading those tokens? Yeah, USDC, Martin, that's a good example. Yes, tell me, Dante.
I've made a token before. I've also bought some like meme tokens from on Solana, but yeah.
Nice.
One.
Nice. But that fun. So these tokens here, people, we are speaking about a very common usage on the Ethereum ecosystem, Solana ecosystem, as Dante is saying, you know, that are smart contracts that can represent the ownership of fungible or non-fungible assets other than the network token. Yeah, the network token itself has a very straightforward and unquestionable utility that is acquiring block space. If you pay a transaction, if you sign a transaction, pay that money, you can be included in a block by a validator. So the utilities there is unquestionable. But other people want to launch all the tokens using that block space. Not only Ethereum, people want to do like stable coins like USDC. They want to do meme coins for some reason. They want to do utility tokens. They want to do NFTs. So there is a standard for creating those. And there are many standards out there. We're going to see a huge amount of a huge list of standards that we're going to go over. And I'm going to teach you this week how to go from reading a standard to applying it in some project. Okay. Of course, learning tokens is important. We're going to apply ourselves to doing that. But also, I want to broaden your understanding on this, that you can do that for other things. For example, later in the bootcamp, we're going to see flash swaps and flash minting and all. We're going to pick a standard and we're going to use this process for coding something too, okay? Upgradability, the same thing. So I want to have this sandbox environment, this laboratory for you to use these tools to learn new things on yourself later. Not because I'm not going to help, I'm here to help, but because then you can start learning even more by yourself with these tools, okay? So those EIPs that I'm speaking about, these Ethereum improvement proposals here, community-made proposals, these discussions, they are not even code proposals in the beginning. They are much more discussions. They would guide the community, the developers, on how to implement certain specifications or standards or even upgrades in the Ethereum ecosystem. Okay. Let me ask you something first before we dive in deeper here. Who owns or who manages Ethereum? Who is responsible for deciding the changes that are made in Ethereum? Do you know? Yes, Dante. Want to pick this one?
The node operators.
The node operators. That's correct. It's not Vitalik, it's not the Ethereum Foundation, it's no dev. The nodes can decide which kind of upgrades in the protocol they would support or not by upgrading the nodes to that version or not. And the developers building smart contracts that would follow these standards or no. Okay. This is a little tricky for us to understand when we are using to centralized applications. For example, Zoom. Who manages the features in Zoom? If I want a new feature in Zoom, so that a bot to auto approve everyone that enters, for example, that would be a good feature. How can I get this implemented? I would need to email Zoom. I would need to have the contact of a person there. I would need to follow the approval process internally for some centralized parties, right? If I want to put a new feature in Chrome, for example, I'll stop playing with with annotations here. So the thing with Ethereum and those blockchains, most of them, is that they are managed by the community. So anyone can come here and propose EIP at any time. Okay, we would have, like, anyone could propose anything. We would have gradual adoption for anything protocol related. The nodes would have this last say if they would apply this protocol upgrade or no. Or for the smart contract design, for example, or wallet design, the developers would have to say that. But all of those discussions, they start like that. Discussions. It starts with an idea, then goes for a draft, then go for review, final, all based on the discussions of the community itself. Today, we are going to speak about application level standards and conventions. For example, the token standard. That is a way for us to represent assets, ownership of assets. But there is also name registration, URI schemes. There are many other standards that we could follow that are just like that, standards. It's not like the grammar that if you fail, the compiler is not going to work. If you create a token that's not following with the ERC20 standard, it's going to work. Okay, the code is going to compile. It's just that it's going to be incompatible with the things that assume this interface. Okay, so if we pick the EIP20, I have some for us to highlight today the ERC20, 721, but just give a look on the list here before we start. Let's start scrolling. Then you can imagine like an elevator music on your head. And I'm still scrolling, I'm halfway. Okay. Today we're going to read all of those standards one by one, right? Of course not. And it didn't finish scrolling yet. You see where I'm going with this? There are too many standards there. It's impossible for one person to understand it all. So I'm going to show the ERC20. I'm going to show this token standard. I'm going to start understanding how it works with you, okay? But then later I'm going to give you a track for you to follow for everything that you want to learn in the future. How would you apply? What would be the best repository for us to start using this kind of things and all, okay? Using the tests and the scripts that we have learned. So if you have developed a token already, like Dante, you launched a token now, might be a little repetitive, but all of you that are exploring these concepts for the first time, this might be a helpful guideline, okay, for you to do in the next September. I will read the standard here with you, and I'm going to try and apply some things by creating a new project, okay? So you remember how to create a new project quickly, that shortcut. For example, if I want to create a new folder here, project 5, I can copy everything from project 4 except node models. I don't need artifacts, I don't need cache, I might not need the package lock too, but let me copy these. Project 5. Okay, I'm not going to install now, I just wanted to open a new project for us to sketch some things. Let me open Cursor here. It's here. So I have this ERC20, the token standard. So every time I'm writing a smart contract and I want it to be compatible with everything that assumes ERC20 standard, I need to follow these requirements. For example, if I want to plug it into a decentralized exchange, decentralized exchanges, if I want to plug it to lending protocols, if I want to put it in a marketplace, if I want to put it in airdrop platform, something like that, I would need some of these functions from the ERC20 there for it to work. Which functions are those? For example, I could have name, symbol, and decimals. Those are optionals, okay, but we even saw that in the past, that we might have there a definition for a name, definition for a symbol, and decimals, okay? One thing that is mandatory, total supply. It should return the total token supply, the amount of tokens in circulation. I must have a function with this name that is public. Viewer should return this number, okay? This kind of number. I must have a balance of function that I pass one address and it should return a value. Okay. So if I were to code this, for example, let me pick a contract here. We delete these things here. Okay, if I were to pick a contract that is a token, ERC20 compliant token.sol, I would create this contract here. Let me do something like this. And then contract ERC20 token, blah, blah, blah. Let me disable cursor. I don't want these many suggestions. Okay, then I would start coding my contract here. For example, I want to have a name function that's like this. It's optional, but let me put function like that, and it would return a name. For example, I could return my token name. You see where I'm going with that, right? So at some point, I will need to have like a total supply. Oops, not here, sorry. A total supply that needs to return the amount of supply in circulation for that smart contract. Like this. And then how I'm going to do that? Well, I should have a variable for that because I might want to mint new tokens later now. So here comes the whole challenge, okay, the whole struggle of creating a token by yourself, because you would need to read through the ERC20, you would need to read through the definition, you need to have a transfer from, you need to have like approval for you to allow other people to change your money, and also that is this whole structure that you need to comply for it to be an ERC20. And this applies for any other ERC that you read, and coding it line by line, iteration by iteration can be challenging. Okay, it can be prone to error. It can be like less maintainable because you might name things differently. You might use different structures for complying to the same stuff. Okay, so I would not recommend coding it from scratch. Okay, if I'm doing the code too fast here, don't worry. For today, just need a new project and you're good to go. Because we're not going to do it like that. No, I'm not going to create my token like this. I'm even going to delete this smart contract that I created. Okay, now I have a blank project. Anyone knows of a project that we used in this bootcamp? Just by chance, just to see what Hot Hat was. Remember, I used this project just to showcase Hot Hat, but that project could be useful here. Anyone remember the name of that project that had a reusable library of smart contracts that we could pick?
Open Zeppelin.
Open Zeppelin. Let's get to that again. I didn't use that as a showcase just by chance. It is one of the best projects to use as showcase indeed, but it's also useful because Open Zeppelin Contracts Library is a library where you can import pieces of smart contracts for secure smart contract development. For example, you have an implementation standard for ERC20 and ERC721 there with community vetted code that was used for transacting billions of dollars and now, that you can reuse those solidity components like a Lego or something like that, like a composable building blocks, to build your own smart contracts. If you want to build a complex stuff, you don't need to reinvent the wheel all the time. You can reuse some of these components out there. Okay. So for example, I want to create an ERC20. Oh, I want to create an ERC721. I would come to those two components that I have here and all of the derivations of these components. And I could just import ERC20 from Open Zeppelin contracts in that folder. We even saw that in lesson 5. And then when we want to create a contract, for example, this token, GLD token, I can just inherit it from ERC20. Interesting. If I want to create an NFT, a non-fungible token, I could just import ERC721 or some kind of ERC721s from this other folder. And then I can say, hey, this contract that I'm trying to create, for example, is a tokenized game item. I want it to be an ERC721 and then I create it like this. Okay, so it's all used on the base of inheritance. Okay, let's hover over this concept once more. I know that I covered that on the first week very briefly, but now we want to understand that again. Inheritance, it is a way that we can make a contract, copy the code of another contract and append it or override it, not the state on chain, remember? So we can pick all of the functions that we want to all of the state variables and functions that we want to import from another contract. We want to inherit from the other contract and put there as if it was part of the inherited contract, where we can override things that are virtual. We can access things that are public, external, and internal. We cannot access things that are private, remember? And we can code more things on top of it. We can add more functions, okay? Again, it's not about the things that I have already deployed. It's just about copying the code of a smart contract. It's more for the developer than the user, okay? So when doing inheritance, for example, you have this contract A, and then B and C inherit from A, and then F, D, and E inherit from those. Okay, so in these situations, you would have different returns cases. Okay, this is going to be important for Thursday's lesson, where for Thursday, yes, for Thursday's lesson when we have one situation like this, because depending on the graph of inheritance, depending on who you inherit first, who you inherit second and third, and all. Solidity would, when compiling that smart contract, would arrange those definitions a little differently. Okay, for example, if D and E are inheriting from B first and then from C, they would pick the functions of C with overriding all the things that they're inheriting from B. But F, for example, that is not inheriting from C, it would pick everything directly from B instead of C. Okay, we're going to see some cases like this. Imagine that you have this call graph later. Okay, we're going to see contracts that inherited from 1, 2, 3, 4, 5 things. In the future, this is going to be very important for you to understand what is going on under the hood. Okay, so instead of coding the smart contract from scratch, as I was doing here in this contract folder, I'm going to suggest another path. I'm going to suggest that we install Open Zeppelin contracts here, okay, with npm yarn or whatever dependency, the package manager, actually, dependency manager or package manager that you want to use here. And we're going to inherit things, smart contract pieces and components from this library. This library doesn't have like a CLI or anything like that, like hot, but it has a lot of components for us to import from it. So using npm here, I'm going to run this command, and this is the part where you can start coding with me to pick your folder, create a new project. You can copy from a previous exercise. Then you can install Open Zeppelin contracts there, remove the other contracts like ballot and all, and we can start using it. So instead of cloning Open Zeppelin directly like we did on lesson 5, here we're going to add it as an npm package. Okay, that's good. That locks a version. We are not always using the main version of Open Zeppelin. Sometimes you want to use the version 4. Sometimes you want to use the version 3. So there are different packages for each versions. Here we are installing with npm instead of cloning the main branch from Open Zeppelin. Okay. And then when we want to create a token, for example, an ERC20 called MyToken, or an ERC721 called MyNFT, I can create just with that. Let's create this MyToken. me open cursor, create a contract called MyERC20.sol, and I'm going to paste this code. This is going to import from ERC20.sol. Say my token is ERC20. So if I do a control click here, go to definition. Maybe I need to open cursor again. Okay, let's try again. Loading here. Let's wait a while. Try this. It's still loading, but I'm going to show it in a while. When I enter this file, now I can. So this is the whole ERC20 definition that I have from OpenZeppelin, doing all of the needed work for me. So there is this total supply that I was speaking about. There is name, there is symbol, there's a mapping of allowances here. There is another mapping of balances here. What a crazy structure. We're going to understand all of that. There is a constructor function that requires a name and a symbol. There is a function to return the name with this structure called encapsulation. Okay, we're going to go through this structure in a while. For creating your token, we don't even need to understand the whole thing of ERC20. We just need to import, declare here in the constructor, and we're ready to launch a token. 2019 feelings, everyone launching a token. 17 to 19 was crazy on that. Okay. If you want to code like a pro, always name what you're importing. ERC20 like this, okay? It doesn't change what you were doing. It's just that now I have this name it import explicitly there in line 4, so that you can it's more maintainable, so that you can state clearly what you are trying to import, because one source file could have more than one definition of smart contracts there. So when you import like this, you are naming exactly what you want to import from that file. It doesn't change anything at all. It's just not readable. Okay. And if I want to create an NFT, I can just create this contract. This MyERC20.sol. New contract, MyERC20.sol. This is importing, this is inheriting from MyERC721 that is imported from this file. Okay. Any questions about the usage of OpenZeppelin so far? No questions?
Actually, what's the second parameter in the constructor? For example, this one says MTK and then NFT.
Yeah, those are going to be stored. The first parameter as name, and the second one as symbol. Okay.
All right.
It's not going to be used inside the smart contract, but for the humans interacting to it, it can be very helpful. Okay. Lauren, do you have a question too?
Yeah, for the sake of clarity, to use OpenZeppelin, do you need to copy some of the code into the project file folder, or how do you code it?
For using OpenZeppelin, you just need to install it like this. Okay.
In the given folder. Right?
Yeah, you need to have a project like we had or something there that you install it first, and then you can inherit it from the usage of your smart contracts. So you install it first. It works with Foundry, works with Hard Hat. Foundry, that is a little complexity here, but it's easy to solve with Hard Hat. You just install with npm, and then you can use by just importing them inside the contract that you want to use later. Okay.
Does it mean that it copy pasted from GitHub all the source code?
What do you mean by copy paste?
I mean all the contracts, ERC721 and all the other are code source related, right? There is a source code in OpenZeppelin folder.
Yeah, it's going to import these and it's going to use inside your contract. Not everything, just the things that you import, okay? Is this your question? You can find all of these here inside the node models. If you go for Open Zeppelin, you're going to find all of these contracts now loaded to your project inside node models, like all the tokens that we have here, the 1155, 721, 20, and then you can use all of these tokens and all of their extensions inside your projects just by importing them like line 4 here. Okay.
Okay, thanks.
Okay, but there are still a lot of things that we don't understand in these smart contracts. For example, we have this definition of allowances here. Yes, we can approve other people to spend our money with ERC20. There is a reason for that. We have those events here that we should understand too. There are a lot of components and pieces of this smart contract that we should understand. I even mentioned about the role-based access control, role-based access features in the past that you could use libraries like OpenZeppelin for doing those, like owner, like who can control that smart contract. No, we're going to see all of that by coding scripts. Okay, just to review this weekend's project, we could write tests too. We could write unit tests in TypeScript to test those functionalities, like minting tokens, like transferring a token to another address, the console log, the balance, and all. I could write tests for all of this, but to review the weekend project, I'm going to write scripts for that, test scripts, okay, so that we do something and we print in the screen what is happening, okay? So we're going to do one exercise like this. We're going to build a contract with Open Zeppelin contracts, okay? We're going to do one extension of these contracts to be able to mint new tokens. We're going to see that by applying access control standards or components to the smart contract, okay? Sorry about that. Raja asked it here in the chat, it's possible to override Open Zeppelin functionalities. Yes, they are composable, and whenever we are stitching them together, we might want to tweak a thing or two for them to connect or to implement them, okay? So they are much more like building blocks for you to put together and engineer them. This is not the best word, but this is what came to my mind. Then actually standalone things. So you don't use a smart contract from Open Zeppelin out of the box usually. Usually you customize it around, okay? And for that, you need to understand it well. So we're going to do these scripts later for us to test what's going on. And we are first going to use these contracts, exactly what I explained to Raja, by extending them, okay? So I'm going to inherit 1, 2, 3, 4, 5 different smart contracts inside one smart contract to compose all the functionalities that we want, okay? So we can override things as we need. We can call the super contract, like the inherited contracts, as we need. Okay, so let me clear some of the tabs here. So we're going to do exactly that to apply access control. We're going to apply this kind of technique of access control, like who is allowed to do this thing in my smart contract, like we did in this weekend project, as we had like ownable, the owner, defined it in the constructor, the designation owner and all. We saw that we can restrict operations with an owner. We did that in the Hello World smart contract. We saw the chairperson in the ballot. But today I'm going to introduce this other pattern called role-based access control. Okay, so that I can have different levels of authorization inside the same smart contract, and more addresses. I can have different addresses, 3, 4, 5 different addresses under the same role. Like I could have like 5 owners for a smart contract, for example. Your whole group. I guess you interface with that in the last weekend process, right? Only one person per time could be the owner. So only the deployer could do this and this and that. So what if you can now have 2, 3, 4, 5 people doing the same function, the same set of permissions in the smart contract? Now you can with role-based access control, okay? So that you define these roles, for example, moderator, miner, meter, admin, whatever, and then you can check for each function inside the smart contract if that person has that role or not. Okay, I'm going to do that with this example here, implementing role-based access control for supply control in this smart contract. Okay, I'm going to do that in a little while. If you ever get confused with stitching those smart contracts together now, there is a wizard for that. Okay? I'm not going to use this today, but remember, I'm going to see that a lot in this bootcamp, that there is a contract wizard that you can pick from OpenZeppelin. Okay, so that it can guide you to build your own smart contract. Let's do like this. For example, I want to create a token that is mintable with roles, access control. So this is the code as we have here in the constructor, in the mint function. It seems like it's a little different from what I have in my code. This happens because those versions of OpenZeppelin, they change time to time. You need to consider changing from major versions like version 4 to version 5. It might not be 100% backward compatible too, okay? But for example, for owner, they change a little. For example, they find the owner as a parameter in the constructor instead of the deployer. Here they have something similar. I'm going to show how to navigate, but as a rule of thumb, whenever you want to create a ERC20, 721, 1155, you can compose it here very easily, very quickly by picking the options you want from the wizard. Okay, this is what we're going to do today. You know how to run scripts, right? We are not going to do things on the testnet today. You don't need to work with gas and all. I'm going to use the hot runtime environment for running those scripts, okay? But we are going to need the syntax from last week. So it's good if you can recall what those things are going to do, okay? So I'm going to create some scripts here. For example, I'm testing the ERC20, right? So I can create myToken.test or ERC20.test, whatever name of the script that you want to do. For example, ERC20 test.ts. And I'm going to put this code here. Okay. This code is not new for us, right? We have used VM with hot in the past. we had this structure of a main function and then calling the main function in the past, right? So we have used this in the past. We have used the public client in the past, inside tests and inside the scripts too. And we have used those accounts, those pre-funded accounts inside a Red Hat environment, right? So here I'm just reusing that inside this test script for us to understand how a token would work, how this ERC20 would work, okay? So for example, the first thing that I want to understand, what happens when I deploy this contract, my token? Let me copy this. And let's deploy here. And keep the two. What happens when I deploy a token contract? I'm going to pick this VM from Red Hat that's going to be plugged into the Red Hat runtime environment now, and I'm going to deploy this contract, my token, to this address. It's going to be deployed at this address. This contract, my token, there has no implementation on itself. It has only like 3 lines of code: contract, constructor, and this, right? So since it doesn't have this much code on it, what can I call on it? If I call, for example, a function that's not here, for example, there is no function like function play game. There is no function like that, right? So if I try to call this function, if I try to call token contract dot play right play game, there is no function like this, right? You know this. You know that if I try to call a function that it doesn't work, it's going to give me an error, right? So I have not defined a total supply in that smart contract directly. So what would happen if I call this function total supply here? I don't have this function total supply defined. What's going to call? What's going to happen when I call? Ivan, you want to take a guess?
Well, it goes up the inheritance chain, so it calls it on the what you inherited from.
Perfect. Perfect. Let me know if everyone understood that. Since I'm inheriting this from ERC20, I don't need to define those functions again and again and again. Since I'm inheriting, I already have all of these functions that I have here. For example, total supply, that is defined here, that just exposes total supply now. I have it there to call. Even though total supply, it is private, you see, I cannot access it directly from an inherited contract. I can access it from this total supply function that I have here on line 85. Okay, this is the magic, the brilliance of this pattern. So when I'm running this test, I can pick this total supply and it's going to be 0. Let me run that in my terminal. npx hat run, and then I'm going to pick scripts, ERC20 test, and it should compile my smart contracts and it should run that script. Okay, waiting a little. So the contract was deployed at this address, and I have 0 total supply. Okay. Questions here? Yes, Laurent.
So the contract was really deployed on the blockchain?
It is not in a public testnet, okay? It is in a local blockchain inside the Red Hat runtime environment.
Okay, thanks.
And how to increase this total supply here? How to get more tokens in circulation? Do you know how people usually mint those tokens inside ERC20s? It is with a function exactly called mint. The problem is that by default, by the standard, there is no mint function available, like token contract right mint. There is no public mint function available in a ERC20. Did you know that? There is a mint function that is internal. Let me show that for you. There is a mint function that is internal here, this one. It's not possible to call it from the outside, and it would update the address of the person that is receiving this amount with this value. Would update to add, okay? That is the whole structure here on why this update is there, because they have hooks that you can do before and after, whatever. But this is minting. I cannot mint for the address 0, as we see here in the line 222. But whenever I call this function mint with an underscore before, I can increase this value amount of tokens to that account, transferring it from the address 0 to that new account, that account that was specified. But since it is internal, there is no way to call it. There is no way to pick the token contract and write the mint to the mint function, because it is internal, right? This is by design. Every ERC20 should have its own minting logic. Initial supply, or you do some game, or you do some lottery, or you do some voting. You need to do something in order to be able to mint more tokens. It's not like a block reward, every block, like the network token. You would, and it was designed so that you would need to implement some minting logic of yourself. I'm going to suggest a very centralized way to do this. Okay, that would be implementing initial supply so that whomever deploys that token would have control over the whole supply. The deployer of this token is going to receive at the constructor, at the deployment, 10 tokens, 10 units of these tokens, multiplied by 10 at the power of decimals. Okay, this is about that big number operation that I told you in the past week. You don't need to worry with that yet. Tomorrow we're going to do a challenge exactly about this. But here is because whenever we are working with blockchain, we deal in decimals. Okay, in Bitcoin we deal with satoshis. In Ethereum we deal with Wei. Okay, so those tokens, they would have decimal parts of it. We're going to understand well. We're going to understand why very well in next lessons. But today, just reuse this information as it is. I do have a lot of decimal places inside my smart contract. So now when I have this contract like that, and if I compile and run that script again, I'm going to have this total supply, because I have defined it in the constructor. So the total supply is 10 with 1, 2, 3, 4, 5, 18 zeros here. Okay. Good. Now, you asked how deeply do we need to know JavaScript to write those scripts? So if you know that syntax that I have sent you you in a link on the lesson 4. Learn X in Y minutes, remember. So learn TypeScript in I minutes. That tutorial can guide you through the whole syntax that you're going to need in this bootcamp, okay? Variables, definitions, function calls, this kind of stuff, okay? And it takes like 2-3 hours to go over this. You don't need to write a lot of things in this bootcamp. You just need to copy a little bit of things, understand what I'm doing here or there, so that you can do the same thing in the weekend projects, okay? For next week, yes, for writing applications, you do need to know a lot of JavaScript and TypeScript syntax, especially about like React or backend stuff and all. But for today, for this week, it's not that much. The link is there on lesson 4. Okay. Lesson 4. At the end of lesson 4, you have this quick guide for TypeScript here. Okay. Good. Just go there, lesson 4. You're going to find it very easily. Okay, so we could add initial supply so that when I deploy that smart contract, I have all of this money in my possession, right? I can transfer it around now. Yes. For production smart contracts for tokens that you would use it normally, you cannot rely on one person, one address. Maybe it's a multi-sig, yes. Maybe it's under the DAO, yes. But usually you cannot rely on a single address to handle it all. It's very dangerous. You could lose access to this address. Someone could steal the private key of this address, you know. So there are some techniques, for example, the role-based access control that I have mentioned a while ago, that allows you to dilute this power, to give this power to more people and to combine different functions. You don't give all the powers to one person or to one set of persons. You can combine different functions. These people can approve, these people can mint, these people can audit. And then these people, when we have an audit and an approval, it can allow the mint to happen. You can have a whole control structure on your smart contract with different people, different addresses that would compose this requirement, that would stack this requirement for doing something. Here I'm using a very simple pattern where I have one tag, one label as a minter role, and I'm going to grant the role of minter to the deployer. I'm going to give this role of minter the person who can mint. Remember, the chairperson is the person who can give rights to person to vote. So here we're giving this right to mint to the deployer. So it's quite like what we had here in terms of centralization, but it's a demonstration of what you can do with it. Okay, so that when I have this function mint, I require that only the persons with role minter can call this. Okay. Let me copy this. Let me paste in the smart contract. Okay. We keep the first 2 lines. Okay. Look, people, how this is being done here. I'm importing ERC20 from here. I'm importing access control from there. And I'm joining these two inside a single smart contract. So my token is at the same time ERC20 and my token is access control too. So that I can use both functionalities inside my smart contract, inside the token that I'm building. Okay, so I don't need to code those two things by myself. I just need to integrate them correctly. So my token now is an ERC20 with a tweaked mint function so that only the people that has the role of minter can mint that token. Okay. So you could give this role to a trusted entity or something like that. Yes, Browns, you have a question here?
Okay, yes, I have a question. So my question is the only row, is the only row imported from access control?
Yes, this only role, I had this in the documentation here, sorry. This only role, I had it open. Access control. Here. The role-based access control, it's going to give roles for people like moderator, meter, admin, and all, and anyone can check if this caller has this role or not by applying the only role modifier to that function. Okay, simply like we had the only owner, similarly to what we had with only owner, now we can do with the only role modifier. Okay.
Okay.
Okay. Yes, Yvonne?
I found the solution. Thank you.
Okay, good, good. Dante?
Can you set multiple only roles?
Yes. To go for the definition here of only role or only role, it requires one role like this, and then you can do only role for this and role for that. Okay, you can pass as a parameter, or more semantically, if you have a role that would be the combination of two other roles, would be interesting to create this third role here. Like this super role, you know, a manager role, whatever role that you want to do, like a director. Imagine that you have an elevator role. That would be the combination of those, because you never know how this can play out. Maybe you want to remove that person from this role first and then do this other one. So you can create new roles here, or you can compose them directly inside the functions. Okay. Raja asked if it's possibly safe to mix and reuse those contracts. So the more you alter, the more things you do with them, the more risk you have. Okay, you need to know very well what you are doing here when putting those together. Okay, it's like assembling a bomb. Okay, every component that you get from stock, they are quite safe. Yes, but when you put the trigger together with the explosive, together with the circuit, the remote detonator, and all, if you do a wrong wiring, it's going to blow on your face, right? So the same thing here when you are doing a smart contract. I don't know if you have experience on assembling bombs, I hope not. But the metaphor here is because it's dangerous. Okay, I'm trying to say that the assembly smart contract is dangerous. If you do a wrong connection, it could blow up too. Okay. Conrado, you have a question here?
Yeah, my question is about the gas. If you put more information in the constructor, is gonna spend more gas and the deploys be more expensive, or just one constructor is gonna be okay?
Yeah, the more things you do here in all of those functions, the more expensive you're going to have a smart contract. Okay.
Okay,
More
thanks.
operations you do.
Yeah, so if I put more logical in the access control, you're gonna spend more in the contract to deploy.
Yes. Everything
Okay,
you inherit, like access control, contract, B, contract, C, everything you inherit is going to add to the bytecode. It's going to cost more to deploy. And the functions, the more you add to it, the more the cost to call to, okay?
okay.
Important consideration too. So let me demonstrate that in the script. so that we understand what is happening here. For example, let's fetch this row code from the smart contract here in the script. Let me fetch this code, this mint row code from the smart contract. I'm going to try and deploy the smart contract and call this function mint from the account to. Okay, I had this question from a student in the past, how you deploy the contracts with, how you call the contracts with different accounts, you know? So in the tests, I had the contract, the token contract being deployed with the account, and here we have the contract being attached to another account, okay? This is different because I want to show deploying with one account and calling from the other, okay? And if I call like this, it's going to fail. It's giving me this error because I haven't compiled my smart contract. I can just compile here. It's going to update the artifacts and all. And then the type checks are going to work. Okay, now it works, you see. And what I want to test is that if I try to mint for an account, for the deployer, for example, 10 units of the token, 10, it's using pass ether here. We're going to understand why in a while. Don't worry with this, could be just 10 and whatever. When I try to do this mint with the account 2, it should give me an error of access control unauthorized account. Let me demonstrate that for you. So I'm keeping all of the past operations that we did. And now when I try to, did I save? I haven't saved. So this is the problem. Let me try it again. Now that I save it. Happens more than you think. So if I try to mint, now I'm going to have this problem. What a big error. So this error. Virtual machine exception while processing a transaction. Access control unauthorized account. This account 0x3C44, it's not it does not have this role 0x9F2D. What is that? What is this role? What we have of error here? So this access control unauthorized account. What is happening here? Let me show that for you. Let me log, do a console log on this code. It's like this code. I'm going to print that the code is this. And let me console log this account to address. Okay. Let me do that after the error, actually. So I'm fetching the code from the smart contract. I'm trying to do this mint transaction, and then I had this error. This account is missing that role. Let me see what this error is, what those things are. So maybe I did not save it. So log. It's giving the error, of course. After it gives the error, it catches and ends the process. So I need to do it before. We do like this. I already have this in my console. Okay. So this is the code 9F2DF0, and this is the address 0x3C44. So what is the error saying here? Scroll up to there. So unauthorized account, this account 0x3C44, it's missing the role of 0x9F2D. Okay. So this is the error that is happening. This account 2 that I'm trying to call is missing this role that has this code. Okay. Why using a code for the role instead of the string? The string would be much more readable, right? Yes, it would, but it would be more costly, would cost more gas. So using a tag, like a symbol for each row, that's very difficult to collide this, to collision these hashes. It's almost impossible to collide a role name with another role name doing this. I can translate the role to a byte 32. It's more gas efficient, okay? It's not that readable. Never get those errors, we get crazy. But what's happening is that this address is missing this row. Okay. So when I try to do this mint transaction, it is failing because of that. So what if I give role first? I'm going to use my deployer, the deployer of that smart contract, to grant the role of this meter role, this code to the account 2 before doing the mint. My scroll is crazy here. So I'm going to do that before doing the mint. So before doing this mint transaction, I'm going to give the role, and then I'm going to do the mint transaction. Okay. I'm going to pick a bunch of information in one go from that smart contract using this promise.al, so that I'm going to get the name, the symbol of that smart contract, the decimals, the total supply in one batch, in one call. Okay. And then I'm going to log all of this. Okay. I had it there already. So I can remove this and I can print it there. This is going to do a promise.all, is going to wait for all of these promises to resolve. So now that I have given the role, granted the role for that account 2, the account 2 should be able to mint these 10 new tokens to that recipient, and I should be able to log the new total supply here after this call happened. Okay. I could even do like this. This was total supply, total initial supply. I should have named it that. The supply at the beginning of the deployment, and this is going to be the total supply after the mint transaction. Okay. Conrado, you want to ask something here?
Yeah, I think it's okay because it puts in an array, so you have to carry with the index to be the on the order name, symbol, decimal, so supply.
Yes.
If
Since
you
it's
need
an array, yes.
Yeah, okay, yeah, it's just that.
Okay, good. Now you asked how you are aware of what you need in the script. So tomorrow I'm going to do a challenge together that is going to exercise and guide you through thinking of those things. Right now I'm giving them, so you are just receiving and accepting. Okay. But tomorrow I'm going to exercise this critical thinking. What should I know? What should I look for when doing a challenge? Okay, and we're going to have 2 lessons just for that, to exercise with you all for building a smart contract and using the scripts for that. Okay. Let me show what is going to happen here. Before we were having this error, let's see what we have now. Marco, this promise.all here is going to call a lot of things from the blockchain, the name, the symbol, the decimals, the total supply in one go, okay? Instead of doing it again and again and again and again and again, we can get them all in one go and then display this information for the user. Okay, it's going to be common to do that when we do the front-end development. Here doing a script is very simple. My initial supply was this, and then I deployed a smart contract with this name, with this symbol, decimals, and then my total supply changes for that after I did the mint. You see, there is no error anymore because I did a transaction to grant role to this account 2. So when the account 2 makes this transaction, it works. Okay. And pay attention one thing here, people. If instead of using this function parse iter, if I just minted like 10, I want to mint like 10 tokens. 10 like this. If I run this script now, I would see that the mint would not be that successful. It would work, it would be included in the blockchain. But instead of having 20 tokens here, actually, I would have 10 and a little decimals. Okay. We're going to see that tomorrow too. Minting dollars, it's different from minting cents. Okay. I have 1 million cents of dollars. Is that a lot of money? Well, it's 10K, it's solid. But it's not $1 million, you see? So 10K, it's good money, but it's way less than $1 million. So the decimal things is very important here for us. Even with 3 decimals, it's already a big thing. But imagine 18 decimals. Okay. Abhinav, you have a question?
Yes, sir. While we are minting any tokens like ERC20 or 721, where are the tokens coming from?
They come from the address 0. It's a very technical detail, but it's interesting. We saw it there. The from value is set to the address 0, but the address 0 doesn't have balance. Okay, just because of the event here with the transfer event, we're going to see how that goes.
Okay.
How the information works here. Okay, but it's not about accounting. It's not about how much money left the balance of the address 0. Okay, it was just created out of thin air. Okay. Trust, I don't handle the videos. Okay, Encode Club handle the videos, so I don't think it's possible to have them in the same day. Okay, sorry about that. I'm going to do one exercise here with the transactions, sending transfer, actually sending 2 tokens from account 1 to account from the deployer actually to the account 1. Then I'm going to wait for this transaction received, and then I'm going to display these balances. Okay. Dante, you raised the hand. You wanted to ask anything before we proceed?
Yeah, on the total supply, I'm getting an error right there.
Well, yeah, I changed this line 9 and 10 here, so that instead of total supply, I changed it the name for total initial supply, something like this.
Excellent, thank you.
Okay. So after I do this transfer, the balance of account 1 should increase, and I can get the balance with this function balance of. So it was 0 before, it should increase. Let me show that for you. So now the balance of this account 1 is 20. My balance is 18 tokens and 20, no, it's just 2 tokens. But it's difficult to read this, okay? It is 2 or it is 20. It is 2 bazillions decimal units. I don't even know how to spell out this number. So there is a way to do it quickly and easily. That is a helper function that we can put I have it in the documentation. Just need to find it here. There is a function called format ether that you can import. You can import together with parse ether. You can import this function format ether. Okay, so that when displaying this balance, caution with this ellipsis here, don't copy it. You're going to alter the line 2 to add format ether, and then you're going to convert it here. Instead of using the normal balance directly, we are going to format this balance with this function format ether. Okay, so instead of displaying with these zeros here and there, I can use this function to format it correctly. So my balance is 18 MTKs. Okay, makes much more sense. The balance of account 1 is 2 MTK and not 20, not 200. Okay. It's much easier to see like that when we convert. Just remember that if you change the number of decimals in the contract, for example, if you change the balance of the decimals from 18 to 8 decimals, when doing these conversions, you would need to use this other function format units. You would need to mint with different values and all. Okay, we're going to see a lot of that tomorrow. Okay, pay attention on this number of decimals, this definition of decimals, 18, 8, 10 decimals, 2 decimals, 0 decimals, okay? Because it's going to be a big part of what we're going to discover about big numbers tomorrow, okay? Arda, you asked about these local ether scan or something like that. I'm going to use a project next week called Scaffold ETH. Okay, Scaffold ETH to that uploads an app bootstraps an app on your local host where you can see your local chain. You have a local block explorer. Okay, you might do this thing that you are asking. Good. So this is writing scripts to learn something. You can write these scripts by yourself. You want to know how the allowance function works. You can write a script to test the allowance. You want to know how the burn function works. You can write a script to test the burn function, okay? And then you do a console log. You know how to write scripts already, right? You did that last weekend. You did the scripts to test the ballot smart contract, right? Now you can, as an optional homework, now you can write scripts to test whatever you want here from the tokens, from the ERC20 and ERC721 to see how they work. Okay, you could write test scripts too if you want with the Mocha, the testing syntax and all. It's going to be very helpful. Or if you want to test something very quickly, you do there. You write a TypeScript script and test it very quickly. Okay. Browns, you wanted to ask something? Raise your hand.
Yes, I wanted to ask something. Okay, we were talking about the decimal, the values, yes. So my question is, those values, are those values constant? Are those values constant? Yes. The values that you are talking of, the decimal values.
These values coming from this and to that.
Yes. Are they constant?
Yes, once you deploy a token smart contract, they are constant forever. It's not possible to change a decimal on the fly, you know. They get stored inside the smart contract. Here, for example, using the ERC20 from OpenZeppelin, they define it as a constant as 18. Okay, we even saw that on lesson 5. But you can change. You can change after the deployment. When you code your smart contract, you can change it, but not later. Okay, so it's a constant here. And it's for display purposes only. It's not for calculation or anything. all the arithmetics of the contract will be done in the actual decimals value itself, not with the display value. Okay. Nathan, if I deploy the MyERC20.sol contract with my personal MetaMask wallet address, I could get minted token inside my MetaMask wallet. Yes, you can. It's possible. You can use your .env from the lesson 8 and start coding those scripts in testnet if you want to. Okay. You can even deploy a token connected to all the smart contracts. It works. Yes, Arda?
So for the weekend homework, we published it on a public blockchain. If we remove the public blockchain elements like our reading our private keys and whatnot, could we run the same code in the local testnet? Or
Yes.
maybe even without the -- network Sepolia, for example, do I ever need to change anything from my code?
Yes, we did that exercise on lesson 8, right? We start in the local testnet and then we switch it for the public testnet, right? So the code should be interchangeable. Everything that you do in the public testnet, you can change it for the local testnet too. Okay. Okay. So for today, I still have 5 or 6 minutes of lessons. I want to explain you about those events because it's super relevant for the front end part. It's not relevant for the things that we're doing here with these scripts, calling the function and all. It's just that whenever you want to listen to this information of smart contracts in a front end or in a bot, in a trading bot, in a script and all, you need to get the information from these specific logs. Okay. All of the normal transaction data of a native token is included in a block. Who sent it from, what was the receiver, the intermediary steps, the gas and all, it's there included in the block. But for ERC20 tokens, ERC721s and all, you are not going to have all of this information indexed in the block. Remember, for a smart contract call, ERC20 token is not money. The value is 0. So we don't have the logging abilities that we have in the blockchain, the architecture of blockchain for the events, for the token transfers. What we have is just for native tokens. For example, if I go for Etherscan right now, and if I pick the top tokens, let's go for the list of transactions here. So whenever I have a normal a transfer, for example, this transfer here that I had 12 seconds ago was transacting this value from this contract to this other contract. Okay, so it's a normal transaction. I had all the traces of it and all. But what if I'm calling a smart contract? For example, this call here, transfer from this smart contract. Etherscan can show that it was a transfer of $1,000 from to here to KuCoin. Okay, Etherscan can show that, but for the blockchain, this was a 0 ETH transaction. So it was just data. It was just that. This is everything that the blockchain is going to see. The blockchain is not going to show the historical balances, the traces of it and all. For us to do that, we need to create it ourselves by using these logs that I have here. For example, this event that is indexing the transfer transaction that had taken place from this address here that I have to this other address here that I have. Okay, so this is the data structure that happens in the blockchain for those smart contract calls, those events that we can code ourselves, like we saw here in the smart contract. Like we saw here in the smart contract. We saw that mint transaction where it was this update here. This emit. So whenever you do that yourself, you need to code that. You need to emit any kind of event. You can define the event yourself. What is going to do, this parameter is going to be indexed, so I can search for it. This other is not going to be indexed, you know. You can code this kind of event yourself. And whenever you emit, this is going to create a log there inside the node inside of the structure of the node. Let's see if I can get here. So it's going to create this log there inside the structure of the node. It's going to be linked with the blockchain data. It's going to be associated with the address of the contract. And now it's going to be incorporated in the blockchain and it's accessible forever. Might change in the future, but forever. But the log is not accessible within the contract. Pay attention to that. There is no way for you to access this logging data, this event data inside the smart contracts, not even the smart contract that created them. So it's much more useful in the off-chain board, on front ends, back ends, and all, because because this is not like on-chain data that you can read from smart contracts. This is something that's very helpful for backends and front ends to use, but no, you cannot use that for having like historical averages on the blockchain, to have historical data, to do reactions of one contract to be called whenever another emits an event. There is no such things in blockchain. Okay, we need to build applications, off-chain applications for this to work. The logging functionality is just for proving those logs that they happened, and then you can listen for them off-chain. Okay, you can get those logs from a block. Let me show one example of doing that. That would be this test scenario. Okay, you can copy this. I can create like a event test.sol.ts actually inside my test folder here. .ts. And this is going to pick that my token contract that I had. It is going to do one transfer transaction, and then it's going to pick all the events that happened. Let me show that for you. In px hat test. Then I'm going to test this events test. And then it's going to check that it is indeed triggering the transfer event with the address of the sender and all, with the correct parameters when I do this transaction. So events here are a way for us to pack data and structure data when we do transactions. We can code these events by ourselves. Here we are seeing the transfer event that is similar to an ETH transaction event, yes, but we could do events for many things, like it's my birthday, then I have this event, or someone new created an account, I could have an event for that. See, you can even say which parts of the events are indexed so that you can listen to it, that you can trigger watch events and trigger executions in a backend and a front end based on it, okay? So that you can filter from it, that there are many useful operations that you can do with indexed members, and you have the normal data values that you can put, okay? You can only have 4 indexed members, so this is somewhat of a limitation of the amount of things that you can do. One is the topic already that has this event data. So anything else that is not fitting in the indexed part, you can put as normal data that you won't be able to search for it, you won't be able to watch for it, but you can see there packed, structured inside that event log. Okay. This is a short 10 minutes explanation about events, but this wraps the lesson. We are not going to use the events in this week. We are going to use them in the front end things that we do next week. So you don't need to worry much with this content. It's just that I'm introducing ERC20. There are a lot of events there now that we are seeing. The code is a good part to demonstrate what this is and what this is about. Okay. I'm above the lesson time already. So thank you all for participating today. I hope that you have enjoyed, and we see ourselves next lesson for working with tokens, building a challenge together for working with tokens. Okay, thank you, people. Bye-bye.